Good day, grade 8 learners. In this video, you are going to learn about operations on rational algebraic expressions. Now we're going to talk about Module 5, Lesson 2. Dividing rational algebraic expressions. What I need to know. At the end of the lesson, you are expected to demonstrate understanding of the key concepts of dividing rational algebraic expressions and divide rational algebraic expressions. What's in? Let us remember that there are 4 operations on fractions. We have multiplication, division, addition, and subtraction. Let us have a short review first about division of fractions. So let us have this number 1 over 4 divided by 3 over 2. In dividing a fraction, all we have to do is to multiply the fraction to the reciprocal of another fraction. So in this case, we will be able to have 1/4 times the reciprocal of 3 over 2 is equal to 2 over 3. Then, applying the rule in multiplying fractions, so multiply numerator to numerator, then denominator to denominator. So we will have 1 times 2 is equal to 2, and 4 times 3 is equal to 12. And we can still simplify 2 over 12, so we will be able to get 1 over 6. Let's proceed to number 2. 2 over 7 divided by 5 over 8. So following the steps that we had in number 1, all we have to do is just to multiply this fraction to the reciprocal of this another fraction. So we have here 2 over 7 times 8 over 5. Then just simply multiply. 2 times 8 is equal to 16, and 7 times 5 is equal to 35. So we have here 16 over 35. And just always take note that we have to always express your answer to its simplest form. And in this case, we cannot simplify it anymore, so 2 over 7 divided by 5 over 8 is equal to 16 over 35. Now let's solve this number 3. 10 over 15 divided by 2 over 3. So we will just follow the steps that we did in number 1 and 2. Multiply the first fraction to the reciprocal of the second fraction. So we got here 10 over 15 times 3 over 2, which is equal to 10 times 3 is equal to 30 for the numerator, and for the denominator, we have here 15 times 2, which is also equal to 30. And 30 divided by 30 can be simplified to 1. So, ten over 15 divided by 2 over 3 is equal to 1. You were able to recall your knowledge in dividing fractions. So now let's take a look at this problem. What's new? So we have here 6v cubed plus 18v squared over 6v squared divided by v plus 3 over 6v squared. In this expression, the answer is 6v squared. As we move on to this lesson, we will be able to find out did how did we get the answer 6v squared. Are you now ready? Let's find out together. What is it? How to find the quotient when dividing rational algebraic expressions? We have to remember this pattern. The quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor. In symbols, we have here a over b divided by c over d, which will be equal to a over b times d over c equal to a over d, ad over bc, wherein b, c, d should not be equal to 0. Let's take this example. Find the quotient of 12x squared y over 9a cubed b squared divided by 16xy to the power of 4 over 18a squared b. In dividing a rational algebraic expressions, you have to remember the steps in dividing a fraction. So the first step is you just have to multiply the first rational expression. So in this case, we have here 12x squared y over 9a cubed b squared to the reciprocal of the second rational algebraic expression, which is 16xy to the power of 4 over 18a squared b. So there are two ways in dividing a rational algebraic expression. So in this case, I will be showing you the first way. So after multiplying the first rational algebraic expression to the reciprocal of the second algebraic expression, we just need to factor the numerator and the denominator of each rational algebraic expression to its prime factors. So we have here, so for 12x squared y, we have here the prime factors 3 times 2 times 2 times x times y. And for the denominator, 9a cubed b squared, the prime factors are 3 times 3 times a times a times a times b times b. And take note that the number of variables will depend on the value of the exponent. So let's say for the numerator, this is x squared, so we will factor it into 2. So there are 2x. So for the denominator, we have here a cubed, so we also have here 3a's, and b squared, so 2b. Now let's have the prime factors of this second rational algebraic expression. So we have here for 18a squared b, we got 3 times 3 times 2 times a times b. And for the denominator, 16xy to the power of 4, we have 2 times 2 times 2 times 2 times x times y times y times y and times y. So there are 4 y's. Yes, we're done factoring to its prime factors. So this time, we're gonna just combine by multiplying everything, the numerator and the denominator, and then cancel out the common factors in the numerator and the denominator. So 3, we cancel out 3, 2, another 2, x, y, 3, y, another 3, 2, a, another, also have a, b. And now let's get the remaining factor for the numerator and the denominator. So the remaining factor in the numerator is, we have here x and 3, and in the denominator we have a, b, 2, y, another y, and another y. So there are 3 y's. Therefore, the quotient of 12x squared y over 9a cubed b squared divided by 16xy to the power of 4 over 18a squared b is equal to 3x over 2aby. A while ago, we were able to discuss the first option in getting the quotient of a rational algebraic expression. And this time, I'm gonna show you the second option. So just like the first option, we are going to multiply the first algebraic expression to its reciprocal of the second algebraic expression. So we have here 12x squared y over 9a cubed b squared times 18a squared b over 16xy to the power of 4. So this is the reciprocal of the second rational algebraic expression. Now, apply the step in multiplying rational algebraic expression in which we have to multiply the numerator of the first algebraic expression to the numerator of the second algebraic expression. Same goes with the denominator. So, multiply the denominator of the first rational algebraic expression to the second denominator of the rational algebraic expression. So in this case, we will have 12x squared y times 18a squared b is equal to 216a squared bx squared y. So how did we get it? So we multiplied the numerical coefficient, so the 12 and 18, and then since there is no base with the same no exponents with the same base, just copy the literal coefficients of the numerator. So that's why we just copied a squared, b, x squared, and y, and arrange them in alphabetical order. Now for the denominator, 9a cubed b squared times 16xy to the power of 4, multiply the numerical coefficients. So 9 times 16 is equal to 144, and there is no exponent with the same base, so just copy the variables, the literal coefficients, which is a cubed b squared and xy to the power of 4. So we got here 216a squared b x squared y over 144a cubed b squared xy to the power of 4. In this case, as you can see, we can still simplify this. So all we have to do is just to get the GCF of the numerical coefficient and also the GCF of the literal coefficient. So we have here 72 as the GCF of the numerical coefficient and a squared bxy as the GCF of the literal coefficient. So how did we get it? We just chose the literal coefficients with least exponents. Now, applying the quotient rule of the law of exponent, we will divide 216 divided by 72, and since there are exponents with the same base, such as a squared, such as a, b, x, and y, we are going to apply the quotient rule. And so we will subtract the exponents since it is a division. The operation is division. So let's have this. So 216 divided by 72 is equal to 3, and we have a squared minus a squared is equal to a to the power of 0. And take note, any variable whose exponent is 0 is equal to 1. And we also have b minus b is equal to none. And x squared minus x, so the answer is x, so that's why we got here x. And y minus y is equal to none. So our numerator is 3x. And for the denominator, we divide 144 to the GCF 72, so that's why we got 2. And following again the quotient rule, so a cubed minus a squared, so we got a. B squared minus b, that's why we got b. And we canceled out x. Then y to the power of 4 minus y is equal to y cubed. Therefore, 12x squared y over 9a cubed b squared divided by 16xy to the power of 4 over 18a squared b is equal to 3x over 2ab y cubed. So it has the same answer with our option 1. And it's up to you, what process would you like to follow? Now let's proceed to our second example. We have here 2x squared plus x minus 6 over 2x squared plus 7x plus 6 divided by x squared minus 2x minus 8 over 2x squared minus 3x minus 20. Following the steps in dividing rational algebraic expression, we have to multiply the first rational algebraic expression to the reciprocal of the second rational algebraic expression. So we have here 2x squared plus x minus 6 over 2x squared plus 7x plus 6 times 2x squared minus 3x minus 20 over x squared minus 2x minus 8. As you can see, all polynomials in each expression are all in quadratic trinomial. So remember the steps in factoring quadratic trinomial. So we have here for 2x squared plus x minus 6, we have the factors, the quantity of 2x minus 3 times the quantity of x plus 2. For 2x squared plus 7x plus 6, we have here the quantity of 2x plus 5 times the quantity of x plus 1. And for 2x squared minus 3x minus 20, we have the factors x, the quantity of x minus 4 times the quantity of 2x plus 5. And for the last one, for x squared minus 2x minus 8, we have the factors x, the quantity of x plus 2 times the quantity of x minus 4. Again, remember your knowledge in factoring quadratic trinomial. Now, for the next step is to cancel out those common factors in the numerator and also in the denominator. So, we have x plus 2, which is common in the numerator and denominator, and also x minus 4. We also have 2x plus 5. And so we have our remaining factors here. Our remaining factor in the numerator is 2x minus 3, and for the denominator we have x plus 1. Therefore, the quotient of 2x squared plus x minus 6 over 2x squared plus 7x plus 6 divided by x squared minus 2x minus 8 over 2x squared minus 3x minus 20 is equal to 2x minus 3 over x plus 1. That's it! You already know now how to divide rational algebraic expressions. Now, let's test your understanding. What's more? Directions. Answer the activity below to measure your understanding about the lesson. Use a separate sheet of paper for your answers. Activity 1.2. Find the quotient of the following rational algebraic expressions. So we have here for number 1, 81xz cubed over 36y divided by 27x squared z squared over 12xy. Number 2, we have x squared plus 2x plus 1 over x squared plus 4x plus 3 divided by x squared minus 1 over x squared plus 2x plus 1. For number 3, we have 2a plus 2b over a squared plus ab divided by 4 over a. Number 4, we have 1 over 2m plus 10 divided by 7m squared over 4m squared plus 20m. And for the last number, 5, we have here 8 times the quantity of 10 minus x over the quantity of x plus 1 times the quantity of x minus 10 divided by x minus 8 over the quantity of x minus 8 times the quantity of x plus 1. I know you can just do it. In this lesson, you have to remember this. The quotient of two rational algebraic expressions is the product of the dividend and the reciprocal of the divisor, in which it will be equal to AD over BC, wherein B, C, and D should not be equal to 0. Let's end this lesson with a quote from Helen Keller: "Your success and happiness lie in you." So just keep doing what makes you happy. I hope you learned something from this lesson.